All right, in this video, we are looking at just a few questions dealing with radicals. So I've got four really kind of different types of problems here. The first one, I am subtracting two radicals. And what I find happens a lot of times, students get so used to using their calculators, they never develop a strong ability to do this without a calculator, and they don't really understand what's going on, and that is going to get you into some trouble. So take the time to practice and show your work for how I would subtract these two radicals. Now, the rules for subtracting radicals is the only way I can, like, if I had square root of 3 radical 3 plus 5 radical 3, that would be a total of 6 radical 3, right? I can only add terms with radical pieces to them as long as they're exactly the same. It's kind of like adding like terms, right? Your radical has to be alike in order to add or subtract. So I can't do anything in A with the square root of 200 and the square root of 32 the way it is, but these are both reducible. So here's what I mean by that. 200 is 100 times 2. And I broke it up that way. 200 could be broken down a lot of different ways, right? But I broke it down that way because I know 100 is a perfect square number, right? Your perfect square numbers, 1 times 1, 2 times 2. Oops, that's supposed to be 4. 3 times 3, 4 times 4, 5 times 5. These are numbers you should recognize fairly quickly because they actually have some special properties that are very, very useful. So when I look at something under a radical, I'm kind of in my head scanning to see, do any of these numbers, and this isn't all of them, right? I just did the first 10. If any of these numbers divide evenly into whatever I'm trying to reduce, because when that happens, I know the square root of 100 would be 10, and then the radical 2, I can't do anything with radical 2. The 2 is going to stay inside the radical. And then I do the same with the 32. And depending on what you see, some people might say, hey, that's 4. Somebody else might say, hey, 16 goes into that. 4 and 16 are both perfect squares, but you don't always see it right away. Maybe you say that's 4 times 8, and the square root of 4 is 2. But 8 is also 4 times 2, and the square root of 4 is 2 on the outside as well. So I'm going to have 2 times 2 on the outside, and then this one little 2 left over on the inside, and I'm going to subtract. So I'm going to rewind. Square root of 32, somebody else might have said, hey, that's 16 times 2. This would be the easier way to do it because the square root of 16 is 4, and the 2 is stuck on the outside. So depending on what you see can determine how quickly you get to an answer. Now I have like terms. They both have radical 2 in each term. So 10 minus 4 would give me 6 radical 2. So if you're being asked to add or subtract square roots, that is all you do. You can only add them if they're alike, but before you say they're not, make sure you check and see if you can reduce them. Chances are you will be able to, and they will give you some like terms. All right, the second example here, we're multiplying. Actually, I've got two binomials. This is an example of FOIL, right? First, outer, inner, last, where I multiply first, the outer, the inner, and the last. That is how I'm going to multiply this out. But I do want you to notice these aren't any two random terms or any two random binomials, right? They're actually conjugates, meaning they have the exact same, it's square root of A and square root of B, one's minus, one's plus. Some special things happen when you multiply out a pair of conjugates that don't necessarily happen if they're not conjugates. So works the same way. You can definitely shortcut this, though, if you know the pattern. So going old school, FOIL, first, square root of A times the square root of A, well, it's just A, right? Square root of A squared would just be A. Square root of A times the positive square root of B is going to be the square root of A times B. On the bottom, that's minus the square root of A times B. And then my last negative times a positive is a negative. Square root of B squared, well, the square root of B squared is just B. Maybe I should have written it that way so you can see it. So my last step, here's step 1. Step 2 would be to simplify the square root of a squared is a. Notice these two cancel, and the square root of b squared is b. So that will always happen when you're multiplying conjugates, that it's the first term squared minus the second term squared. So when you start to see that, you should be able to do this pretty quickly, and we'll get a practice in the next question. So hopefully you remember the word rationalize. When we're rationalizing, you can rationalize either a numerator or denominator. It just means get the square root, the irrational number, out of the denominator or numerator. So on this first one, we're going to rationalize the denominator. And I would do that by multiplying by the conjugate. Now, I can't just multiply the denominator. That would be changing the fraction. I'm actually going to multiply by the number 1. Square root of 5 over 2 over the square root of 5 over 2. Multiplying by the number 1 does not change the fraction. I'm allowed to do that. I'm just picking a form of the number 1 that gets rid of the square roots in the denominator. So if you remember from that last example, we said when you multiply conjugates, it's going to be the first term squared minus the second term squared. And you could go through all the FOILing process if you want to, if you don't believe me, but knowing that little fact can definitely shorten your work. On the top, I'm going to just distribute that square root 10. Now remember, you can only multiply inside stuff with inside stuff and outside stuff with outside stuff. So when I multiply the square root of 10 times the square root of 5, that is the square root of 10 times 5, or 50. Those are both inside, both get multiplied together. But when I multiply the square root of 10 times 2, well, 2's outside, 10's inside. They don't get multiplied. They're just going to be next to each other. All right, now let's see if we can reduce some of this. The numerator, 50, is 25 times 2, and I know the square root of 25 is 5, and the square root of 2 is just the square root of 2. Now, 10 is 2 times 5, but neither of those are perfect squares, so I can't reduce that. In the denominator, 5 squared, square root of 5 squared is 5, and 2 squared is 4, and 5 minus 4 is 1. Oh, that one turned out nice, because now that I know that that's 1, then my final answer is just 5 squared root of 2 plus 2 squared root of 10. I don't have to divide by anything. The denominator turned into 1, and I'm done. All right, last question, probably more challenging. I would encourage you to pause the video and try it on your own. You are rationalizing, but notice this time you're rationalizing the numerator. You're getting rid of the irrational part by making it rational, hence the name, rationalize. All right, if you're joining me back, I am looking at this numerator, this messy numerator, and I'm hoping that you're seeing there are 2 terms here. There's that crap underneath the square root, and then there's a 2. So I want the conjugate of that. All that stuff under the square root is my first term. I don't know why I made it a b. Try that again. And then I'm going to make it plus the second term. So that is the conjugate of the numerator. I do have to multiply by 1, so I need to make sure I multiply by the denominator as well. So knowing the trick, right? Knowing the pattern here, I know when I multiply by conjugates, it's going to be the first term squared, 4 plus h squared. I know it's going to be minus, because a positive times a negative is a negative, and I know it's going to be the last term squared, and 2 squared is 4. I'll leave it as 2 squared for this first part. So that's the numerator. The denominator, I'm multiplying all this by h. So I'm going to end up with h times the square root of 4 plus h, and h times 2. And maybe I didn't want to multiply that out all the way. I have a feeling I'm going to regret having done that. When I go ahead to simplify, the square root of, the square of the square root of 4 plus h would just be 4 plus h. 2 squared, it would be 4. And on the denominator, I have this mess. Now on top, 4 minus 4 is 0. I end up with h over h times the radical, and 2 times h. And hopefully you see all those h's will cancel each other out. Be careful. Again, I know sometimes people just want to do that. You cannot divide out of just one term. That h has to go. You got to do them all. They all get divided by h, so that one would go as well, which would leave me with 1 on the top and that on the bottom. So had I not, way back here, multiplied through, distributed that h, it might have made life a little bit easier. I would have just crossed the 2 h's out, but I did, and, you know, you can't take it back. So there you go. All right, that's your review on radicals. Catch you next time.